All right, this is part 2 of lesson 5-7. We learned to create a trend line by just eyeballing a line. Now we're going to learn how to use a graphic calculator to find the equation for line best fit for the data. And we're also going to learn how to use the calculator to find the correlation coefficient. So here's our data. We have our heart rate and our jogging time. And notice as the jogging time goes up, the heart rate goes up. So it's an increasing relationship. It's a positive correlation, it looks like. And we're going to try and model that by using a graphic calculator. You're going to have to kind of watch carefully how I do this. You may have to pause quite a bit, go back to it, because you're going to learn how, a whole bunch of new buttons to use for doing some math. All right. Now to enter data, the first thing we want to do is, I'm going to pause this and resize mine. Okay, so to enter the data, and listen carefully, you're going to press the Stat button, and then press Enter, and that gives you some lists. If you don't see this list or there's numbers in there, you can do a couple things. You can reset your memory, you can clear a list. Don't use the delete button because that'll delete the whole list, and you'll have to reset your memory to get it back in there. But I'm going to put my jogging time in L1. So I'm just going to put 1, 2, 3, 4, 5, 6, 7, and 8 in there. And then in L2, I'm going to put my heart rates. And those are 81, 84, 86, 91, 97, 102, 108, and 112. Now, one quick check you can make is to make sure that you have one value in L1 for every value in L2. So those should match up. All right, so we have the data in there. Now we are going to make a scatter plot of that. To make a scatter plot, you're going to press second, and then y equal. Notice it says in blue above y equals stat plot, which means statistical plot. And number 1, plot 1, press enter. Turn that on by pressing the left arrow, and then pressing enter. The type of graph, right here, that's a scatter plot. That's what we want. The next one over with connected dots, we don't want that. The lists, you'll notice, match up with the lists that you put them in, L1 and L2, which is good. The mark that you choose, you can change that. I'm pressing my down arrow to go down to that mark, and then my right arrow to go to the plus, then I press enter. I like the plus sign better for this. I think it shows up nicer when you graph it. Okay, now if you press graph, none of these would really show up because they're not in the standard screen. To change the screen, you're going to press zoom, and then arrow down till you see zoom stat. That's what we want for when we're making a statistical plot. What that function does is, there it is, number 9. You could have just pressed 9. That shapes the window to fit all of your data. So I'm going to press enter on 9, and there you see it made a scatter plot. Now, just so you can see those values, if you press trace right now, and then your right arrow, you would go right through those amounts. Okay? Now, what we want to do is come up with a line of best fit for this data, and your calculator will do that also. It'll use a mathematical process to average the data. I'm not going to get into that now, but to do that, we want to get out of this graph, so I'm going to press second mode, and that gets me to my regular screen. Then I'm going to press the stat button again, and I'm going to use the right arrow to go to calc. And then number 4 is what I want. It's called a linear regression. And that's the mathematical process of averaging your data and turning it into a line, a linear equation. I'm going to press enter there. If you have your data in L1 and L2, that is the default. You can just press enter. And it gives you the slope and the y-intercept. You'll notice my slope is 4.65 and a bunch of numbers. My y-intercept is 74. So if I round these values, I can say my slope is about 4.65 and my y-intercept is about 74. Let's just use those for now. So 4.65 and 74. I'm going to go to my screen here. So y equals 4.65x plus 74. That's rounding the data. So I'm going to put that equation into my calculator. Just your y equals. Clear those out. And put 4.65x plus, I think it was 74. And I'm just going to press graph to see how nice that fits those dots. If it's a good equation, it should fit right inside those dots, and it pretty much does. So you can see that. Now we can use that equation. It says predict the heart rate in beats per minute after 12 minutes of jogging. So what I want to do is 4.65 times 12 plus 74. And I can just use my calculator to do that. 4.65, go to my calculating screen, 4.65 times 12 plus 74, enter. And so it's predicting about 129.8. Let's round that to a whole heartbeat, make it 130. It predicts about 130 beats per minute. And choose to think about that, is that an extrapolation or an interpolation? And since 12 is beyond my data, that's an extrapolation. All right. So this just has us finding. We're already given the equation, and we just need to use that equation to find to make a prediction. So x is equal to the year at the beginning of the academic year. So that is 2016. So let's put that there. So we're going to do times 2016. And we're going to use our calculator for that. Move it. You can see my numbers here. So we want to do 409.43 times 2016 minus 815.446.71, enter. So it's predicting about 9964 for the cost. So, and since it's just a prediction, we're going to round it. You could probably say it's about $10,000 for a 4-year college in that year, which I think is going to be a little bit low. But, all right. So identify whether relationships are causal. In the following situations, there likely to be a correlation. If so, does the correlation reflect a causal relationship? In other words, is the independent variable the reason for the change in the dependent variable? So I have a student and the grade earned on a quiz. There is absolutely no correlation there. All students can have good grades or bad grades. So we're going to say there's no correlation at all. So we're not going to worry about whether it's causal or not, because you can only have a causal relationship if there is a correlation. Second one says the price of bananas at a grocery store and the number of pounds of bananas bought. Yes, as the price of banana goes up, the number of bananas bought will go down. And is there a direct relationship between them? In other words, did the price cause the number of bananas bought to go down? Yes, it did. There is a causal relationship here. Okay, let's try this. Consider the cost of a family's vacation and the size of their house. Is there likely to be a correlation? If so, does the correlation reflect the causal relationship? In other words, if people have a big house, will they have higher price of their vacations? I think that's true. So yes, there's likely to be a correlation. Bigger their house, bigger houses indicate bigger incomes, and if you have bigger incomes, the price of your vacations are probably going to be higher. Now, so we have a correlation. Does the correlation reflect the causal relationship? In other words, is the fact that they have a big house mean they have to have more expensive vacations? No. People with big houses can have can take cheap vacations or expensive vacations. There is no causal relationship between them. So no. All right. I'm going to stop the video here. You can do the last part on your own.